Hello. So welcome to our second video on trigonometry. This video is going to be about radians, and it's also going to be about special values of the trig functions. And we have a little bit of agenda here, which you can write down so you can know what we're going to be doing today. All right, let's get started. So we're going to be talking about radians. This is something that I bet about half of the people in this class have seen, half haven't. At least that's been my experience from that little diagnostic I gave you last class. So radians aren't too bad once you kind of figure out what the idea is. The idea is that degrees mathematically is not the ideal way to measure angles, right? So when humans started measuring angles, they had to just come up with their own units. They had to decide what a full circle was going to be. And so eventually they decided pretty much arbitrarily that a full circle should equal 360. It wasn't completely arbitrary, and I'll say in class actually why they thought that, but that's just all a degree is. It's just a measurement that means that 360 is going to equal a full circle. And there's some reasons why degrees are nice. 360 can be divided by lots of numbers, so it's easy to talk about lots of different nice angles that have whole numbers, but it's still a pretty arbitrary measurement, so it's not going to have the best mathematical properties. There actually is an analogy for this. Like, remember when we were talking about exponential functions, we could talk about having 10 as a base for an exponential function, and that's kind of nice because humans have 10 fingers, and we have a decimal system that is base 10, but mathematically it's not really the best base. The best base is actually e. That's the one that has the best properties. In very similar fashion, the way to measure angles that gives you the best mathematical properties is radians. So what are radians? Well, first off, before I get to that, here's some points on the unit circle in degrees. Okay, and these points are actually going to be important for later on when we talk about special values. So I'd actually encourage you to put this in your notes and to think about how I got it. So I'll tell you how I got these points. I started with the upper right quadrant, and I cut it into half. So that's how I got this 45 degrees. And I also cut it into thirds. So if I'm cutting 90 degrees into thirds, I'm getting 30 degrees and 60 degrees. Okay. Now I'm mirroring that same thing in all four quadrants of this circle. So in the upper left, I'm doing the same thing in the lower left, same thing in the lower right. Okay. And so I don't have all of these numbers memorized. I think it's too much to ask that I just have this. I don't have a photographic memory, so I don't just have this picture memorized. But it's not too hard to get. So if I point to one of these, like this one down here, I'm thinking to myself, okay, I know half of the circle is 180, and then I'm going an extra 30 degrees on top of that. So this down here must be 210. Okay. And all of these numbers, I get that way. I just kind of figure out, okay, I'm going so far, and then I'm adding a little bit more. That's how I can figure out what any of these numbers are. Remember some of the unit circle stuff. Stuff like if we go above 360, then we just keep going around. So if I go 360 degrees, that's going all the way around to where I start, which is always in the right-hand side, and I'm always going counterclockwise, right? Unless it's negative. So if I go above 360, I'm going to be going back around. Similarly, if I go negative, I'm going to be going backwards, clockwise. So this point right here is what I get when I plug 330 degrees in. It's also what I get when I plug in minus 30 degrees. So if you like, you can think about it this way. But then in any case, these points are ones that we're going to be comfortable with. Let's start talking about radians. All right, so radians are another unit for measuring angles. So in degrees, a full circle is 360. In radians, a full circle is 2 pi. Okay, now at first that's awkward for lots of reasons, primarily because 2 pi is not a whole number, and it's not even a rational number, right? So suddenly a full circle goes from being a nice whole number like 360 becoming this awkward number 2 pi, which is about 6.28, right? But here's the good news. I don't think of that as 6.28. I think of it as 2 pi. And when I'm giving an angle in radians, the pi is pretty much always going to be there. And I just have to think, what fraction of pi is this? Okay. So here's the task that I'm going to ask you to do. I'm going to ask you to take all these points on the unit circle and write them in radians. And I'll help you get started, but I think this is one of those things that it's good to think about how you would do this before I explain it. So this is what you're going to be filling in. The units, same unit circles before, all the same points. And that, by the way, that includes the top, left, bottom, and the right points as well. But put these in radians. So I've gotten started for you. The point on the right is 0, as it was before. But if I go all the way around, that's now 2 pi. Okay? If all the way around is 2 pi, then halfway around is pi. All right, because what's half of 2 pi? Pi. Okay. That means that all of these points here are fractions of pi. And what I want you to think about is what fractions of pi they are. So you're going to be writing down all of these points in radians as some fraction over pi, and they can all be, in fact, written as pi divided by some number. The points down here on the bottom, same idea, right? But they're all going to be between pi and 2 pi, right? And if you can get the top points, you can get the bottom points too, basically just by taking all the previous numbers and adding 1 pi to them. So try to get as far as you can on your own. If you can get the whole thing on your own, even better. But I'm going to show you the answer in a second. So pause the video if you want to try filling this out on your own, or if you've seen radians before and you think maybe you can remember what all these points are, give it a shot. Okay, so now I'm ready. I'm going to scroll down and show you the answer. Here it is. Okay, so here's what you can do to get these numbers in the fastest way. So again, halfway around the circle is pi. That's the most important thing. So 90 degrees before, now that's halfway from the right side to the left side. So if this is pi, this up here has to be pi over 2, half of pi. Okay, so then this point is half of that, so it's got to be pi divided by 4. Remember, this is what I get, these 2 points here are what I get when I cut the 90 degrees into thirds, okay? So this is 1/3 of pi over 2, so that means it's pi over 6, right? You can do a little bit of math there. What's 1/3 times pi over 2? This is 2/3 times pi over 2, but it's probably easier to think of it as 1/3 times 180 degrees, which is pi. So that means it's pi over 3. Okay, and then the numbers here you can get the same way. You can think about adding 1/6 to pi over 2, or you can think of it as 2/3 from the right to the left. This point is 3/4 from the right to the left, and this point is, well, just 1/6 away, so it's got to be 5 pi over 6. The numbers down here, I don't have a special trick for these other than to take the numbers I had on top and add pi to all of them, and then just reduce the fraction after that. So again, I'm not saying this is something you should memorize, because I don't have every single one of these numbers memorized. It gets better. You get more of it memorized over time kind of naturally. But just think, like, what's the process that you're going to use to be able to recreate this picture when you have to? Okay. There is a formula for going between degrees and radians. I will show that formula to you in class. You might even think about what that formula is now, because I think some of you might be able to figure out what it has to be. But even with that formula, I don't think that formula is the way that you want to produce this chart. In other words, I don't think What you're going to want to avoid doing in the long run is being able to look at one of these points and say, okay, that's 45 degrees. I'm going to plug that 45 degrees into my formula. Okay, I did that, and I got pi over 4. In the long run, it's going to be faster, and you're going to have a much easier time if you are able to think of this as 1/4 of the way from the right to the left. So that means that it has to be pi over 4. So that's the way that I encourage you to think about it. But the end goal is being able to reproduce this chart when you need to. And that's all the points on this chart. Okay, let's talk about the special values. So here's what I'm going to do for this. Again, I want you to have fun with this. I think this is completely discoverable on your own, and I think you're going to enjoy it and be able to remember it if you can find some of these things, at least some of these things on your own. So I'm going to give you that opportunity. So these are two special right triangles, meaning that these angles here are particularly nice, 60 degrees and 45 degrees. And using your knowledge of geometry, wherever that is at this point, see if you can find what these side lengths would have to be. Okay, without your calculator and without, you know that you could get them from plugging trig functions into your calculator, but that's backwards. What I'm trying to do right now is we're trying to see like if we could find what these trig values are just by using geometry. So that's the goal here. And I'm going to give you a hint. I'll give you one hint to start off with, which is Pythagorean theorem will help you out for both of these. I do think the one on the right is a teensy bit easier than the one on the left. And I'm going to give you a second hint in a second. I'm going to scroll down to a second hint. But see if you can get these on your own. I bet some of you can. All right. Okay, so if I've given you the chance to pause the video, I'm going to scroll down to your first hint. Okay, so I'm going to explain this hint. With the first triangle, what I've done is I've reflected it across and created a bigger triangle. And if you think about that, if this is 60 degrees and I've reflected it, then this would have to be 60 degrees too. But then this triangle, all triangles have to add up to 180. So that means that this angle is 60 degrees. And then think what kind of triangle I've made now, where everything is 60 degrees. What's a kind of triangle where all the angles are the same? And if you remember your geometry pretty well, you might remember that that's actually an equilateral triangle. And if you know that this is an equilateral triangle, I bet you could find this side. And then I bet you could use this side and a little bit of Pythag to find this. Okay. So next I'm going to give you the hint for the second one. With the second one, if this angle is 45 degrees, then this angle has to be 45 degrees as well. Again, everything has to add up to 180. So that must mean that if both of these are 45, I've got an isosceles triangle. So that means these side lengths are the same. Now you might have even been looking at this triangle back here and have guessed, oh, wait a minute, these sides look like they're probably the same. And if that's true, yeah, that's something to go off. So we can label both of those as x. So that means if I use Pythagorean theorem, I've only got one variable. I bet that's going to let us solve for what x is. Okay, so that's your hint. So see if you can fill in the question marks and fill in what x is. And again, after you pause and think about it, I will scroll down. Okay, are you ready? So here are the answers to those. And I've even shown you the algebra I've used to get them. So this side down here being half of the full side, remember this is an equilateral triangle, so this side has to be the same as this one, 1, which means half of that is 1/2. Okay, so this side's got to be 1/2. But if this is 1/2, I can plug now both of these sides into the Pythagorean theorem, and I get 1/2 squared plus this side, which I'm calling x right now, x squared equals 1 squared. I did a little bit of algebra, and I solved it as x equals square root of 3 over 2. Okay. Second one, I worked out that, again, with Pythag, knowing that these two sides were the same, we have x squared plus x squared equals 1 squared. Start to get x by itself. You don't need quadratic formula or anything in this. I could just take the square root here, and I get x equals square root of 1/2, which I can write as 1 divided by square root of 2. But it's kind of nice and convenient and textbooky to have the square root up at the top of the fraction. So if I do that, I get, by multiplying both sides by square root of 2, I get x equals square root of 2 over 2. Okay, so that means that now I know, just from geometry, what cosine and sine are for 60 degrees and 45 degrees. Hey, those happened to be angles on, special angles on our unit circle from before, right? Also, secretly, we now know it for 30 degrees too, because if this angle is 60 degrees in this triangle, this one up here is 30 degrees. So if I switch the focus to this angle, redefine the sine and cosine accordingly, now I even know what sine of 30 degrees is and cosine of 30 degrees is. Okay, so that means maybe you can guess where this was going. We can fill in cosine and sine for all the points on this circle. But that's a big ask for right now. So what I'd like you to try doing, just from our previous discussion, try filling them in for these points here. And that means figuring out, remember our unit circle, the coordinates, the x and the y coordinates of these points are cosine and sine. And we, using those right triangles that we had before, now have values for cosine and sine for all of these points. Okay, so I'm going to show you the answer again in just a bit, but see if you can get it on your own first. Okay, so I'm going to scroll down here. Here it is. Just for those points in the upper right, these are the x and the y coordinates for all of those points. I didn't talk about the points down here and up here, but we don't really need fancy right triangle trig for that, right? I mean, this is the unit circle. It's a circle of radius 1. So this has to be 1, 0, and this has to be 0, 1. But these points in the middle are coming from those values that we learned up above. Okay, so this is what I'd like you to fill in. This is one of the most important things you can have in your notes right now. I've also given the angles in both radians and in degrees. Let me talk about how you can remember this. Okay, again, I don't think memorizing 5 different points and all of their coordinates is really the point. There are tricks for this. Think about the numbers that I'm using. In everything that's going on here, in these coordinates, there's actually only 5 numbers. And those numbers in order are 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. There's kind of a pattern to those numbers, right? And in fact, like 1 over 2 is the same thing as square root of 1 over 2, because square root of 1 is 1. Even the 0 and the 1 kind of follow that pattern, because 0 is actually a square root of 0 over 2, and 1 is the same thing as square root of 4 over 2. So all of these numbers kind of follow a pattern. I don't think you need to know that pattern to remember what they are. But once you have those 5 numbers in your head, it's pretty easy to fill them in here. And the trick is that the x coordinates, if I'm going, let's say I'm going this way, which is counterclockwise, the way I'm supposed to be going if theta is increasing, then the x coordinate is decreasing from top to bottom. So I'm just listing those numbers, those 5 numbers, in decreasing order. But at the same time, the y coordinate is increasing. It's the same 5 numbers, but increasing from 0 to 1/2 to square root of 2 over 2 to square root of 3 over 2 to 1. Okay, so I'm giving you a long-term goal right now, but not that long-term. In not too long from now, I am going to expect you to have basically be able to reproduce this when you need to. And not just that, because I could do the same thing for any of the points in this quadrant. So how do you do that? Well, the points in the other coordinates, like the upper left, for example, all that's changed is that the x has become negative. It's flipped around so that the x coordinates are now negative. Down here, the y coordinates are what are negative. Down here in the lower left, both the x and the y coordinates are negative. Change of scenery. Okay, so here is your homework for next class. Pretty simple. I want you to fill in this entire chart. Okay, and here's how I think you can do this to maximize you going forward in this class. I think you can look at your notes, look at any part of the previous video that you like. Then I would like you to shut this notebook, pause the video, and on one piece of paper, one big piece of paper, draw this unit circle and fill in everything. And let me tell you what that means you're going to be filling in. You're going to be filling in all these points in the unit circle, what their degrees are, what they are in radians. That's what this little line that doesn't have the degree symbol means. What the coordinates of each of these points are, so x and y coordinates. And then in each quadrant where it says positive and negative, you're going to be saying out of the three trig functions, sine, cosine, and tangent, which of those are positive in this quadrant and which of those are negative. So if you can fill in this entire thing, then you know everything about the unit circle that you need to going forward. And that involves a lot less memorization than you might think. So keep in mind that really all you need to be able to do to really memorize to be able to fill this in are those 5 key numbers that we talked about earlier, because all of the coordinates are going to come from those, maybe with minus signs in front of them. All right, give it your best shot, and I'll see you in class.